I'm going to talk about Node.js, and I'm going to do it in the Ignite style. The idea is to have 5 minutes, 20 slides, 15 slides, 15 seconds each slide. So Node.js, JavaScript on the server, built on top of the V8, and the idea is to build scalable network applications. Originated in 2006 by a guy named Ryan Dahl. He was a PhD student, and originally he was trying to build a server in Ruby, and it wasn't fast enough for him, and didn't like the idea that the memory consumption is very, very high due to the way that Ruby MRI using threads, and he just built it in JavaScript. He presented it in 2009 in a JavaScript conference in Germany, and it was a very successful presentation. Joint sponsored him, and the community started to grow, and now we're in version 08. The idea is to create a library which is evented and non-blocking. I'll explain what it is in a few minutes. Based on the CommonJS module system, and it's about 40k lines of code. It's JavaScript that sits on top of C, and you have the V8 at the bottom with libuv, which is the library that wrapping the event loop and the socket pulling, which I'll explain in a second. So I/O is very expensive, and you can see here the comparison between different I/Os, and the RAM disk and network is the most expensive. It takes a lot of time to go and reach to the network for some information. And there are a few ways to deal with I/O. There's the synchronous way, there's forking a process, you can create new threads. And the problem with forking processes or threads is that it's very expensive in terms of CPU and memory. And there's another approach which Node is using, which is event loop. This is the common way to do stuff, especially if you're coming from Ruby or Python. You're making a request and you just sit and wait. And your software, your computer is not doing anything but waiting for the query to come back. And this is a pseudocode of event loop. And it's basically infinite loop that constantly doing a polling on sockets, on changes of sockets, and if there's any change and the socket is ready, only then it makes a call to your function. And that's how in JavaScript you add a function, you're passing the function, and by passing it, you're adding it to the queue that the event loop is listening to, and that's how I/O should be done. There's a few reasons why it's not happening in most languages. Nginx versus Apache. Nginx using evented I/O. Apache is using creating a new thread on each request, and therefore the memory of Apache is very high, and the request per second is not that great as Nginx. And this is the benchmark for Hello World for Node. You can see that it's about 50 megabyte and 5,000 requests per second. It's, very fast. JavaScript, the language, is actually a great fit for evented I/O. In JavaScript, you have something called closures, which is a function have all the state that was available when it was created, it's available and the execution time. So it's great in that aspect. And one of the main design goals is to kind of follow the Unix philosophy and use pipes and use streamings and also stuff that people know, especially JavaScript client JavaScript guys already know. Another aspect is what we talked about before, which is callbacks, and you should not call I/O directly. Always pass a function that will be called when the data will be available for you. Streams is very, very important aspect. Just like a Unix pipe, you can basically get information chunk by chunk, and you can later on pipe it to something else, and it's very great because it's not a lot of memory that you consume, and it's very fast. This aspect is the small core. So standard library in Node is very small. The only TCP, HTTP, file system, that's mainly it. The rest is being built by the community. And the community is using NPM, which is the Node Package Manager, which is a great, great tool for finding stuff, installing just npm install to install new packages, or npm publish to publish your own package. There's about 20,000 packages already. And this concept is focusing on using instead of extending. So you don't have a lot of class hierarchy that you're extending like you have in Ruby or Java, but you just have simple objects with a few methods that you're using or calling. Thank you.